So it's one of the first things that we learn about polynomials actually. And this is what I mean when I say that it gets really tough sometimes, all right? So when this polynomial gx is divided by x minus 3 and x plus 2, the remainder is 30 and 20 respectively. So let's write that down, regardless of how we're going to use it. Given g3 is equal to 30, that's your remainder, using remainder theorem, and g negative 2 is equal to 20. This will come in handy later, but let's write it in this form, easier for us to process. So they say, find the remainder when gx is divided by x squared minus x minus 6. Okay, so this one, you can actually try to factorize this. When you try to factorize this, you find that it is 3 and 2 negative positive. So by no coincidence, you will find that this actually results in x negative 2 and x positive 3, which is in line with the clue that's given to you earlier. Okay, so here's the thing. One of the first things that we learn about this polynomial, right, is that when you have a gx, I don't know what this is, I divide this by a divisor. In this case, x squared minus x minus 6. What I produce on my right hand side is a quotient, right, and a remainder, which still has the same divisor over here, x squared minus x minus 6. Okay, this is your key step over here. You need to start from this, right? So multiplying across, right, you will produce the other form of the same equation. It's the same equation, different form. So this is qx multiplied by this x squared minus x minus 6, and you have an rx over here. Okay, if I were to express my x squared minus x minus 6 in a different form, that means in the factorized form, this will actually be what I've done just now, x plus 2, x minus 3, and then plus rx. Okay, so there's another critical step over here that you need to consider, which is that when you produce, when you write this polynomial in this form, right, this quotient actually deals with anything that makes your polynomial improper. So that means this fraction over here is a proper fraction. Proper fraction means your numerator order is less than your denominator order. The degree of the polynomial in your numerator is less than the degree of your polynomial in your denominator. This is another consideration that you have to bear in mind. So meaning to say, you can let Rx be equal to ax plus b. Why not ax squared plus bx plus c? Because then your degree will be same as your denominator. Not acceptable, is improper. Why not just a over x squared minus x minus 6? Because then you'll be neglecting that there could be an x term. So therefore you assume that there's an a and a b here, an x term and a constant term. Even though one of them might jolly well turn out to be 0. You just assume it's there first. Okay, so hence your equation becomes gx equals to qx multiplied by x plus 2, x minus 3, plus ax plus b. Alright, so this is where your clue comes in, given that g3 is 30. So g3 is actually equal to, you realize that this 3, when you sub into this qx portion, right, we have what we do in cover-up rule. The whole thing becomes 0. So it doesn't matter what our qx is actually, because x minus 3 is 0. Multiplied by 0, the whole thing is gone. So this is just 3a plus b. And this is equal to 30. Okay? And we have g negative 2, which likewise gives you negative 2a plus b. And this is equal to 20. Equation 1, equation 2. Two equations, two unknowns. We solve it simultaneously. So this one we use elimination method. So 1 minus 2. So this becomes 5a equals to 30 minus 20, so 10. So our a value is 2. Okay, so substitute a equals to 2 into, let's say, equation 1. 3 times 2 plus b equals to 30. So b is 24. Okay, come back to the requirement of the question. They're asking for the remainder when gx is divided by x squared minus x minus 6. Okay, so hence, the remainder is ax plus b, right? That's why we let it be. So this is 2x plus 24.